Hello friends, welcome back to my channel AKB Tutorials. So in this channel we are discussing various topics related to mechanical engineering. In this, we are discussing strength of material, and in today's video we are going to see the complex stresses. In last video also we have seen two derivations, and remaining two derivations we will see today. So the third case, that is body is under by axial stress with shear stress. Body is under biaxial stress with shear stress. So this is the most complex case. Now this is the stressed body. The body is under biaxial stress system, means along x direction the body is under sigma x load and or sigma x stress is acting along x direction, and along y direction the sigma y stress is also acting. So that means, this is the x direction and y direction. Along x direction and y direction the stresses are acting, that is sigma x and sigma y stresses are acting along x and y direction. Along with the shear stresses are also acting on the body. Let the shear stress acting is tau xy, so complementary shear stress also will be tau xy acting on the body. So this is the most complex system or complex stress system acting on the body. Now on an inclined plane which is at an angle theta with x direction in counterclockwise sense, what are the stresses developed on this plane, that we are going to find. Now consider there are two stresses acting on the inclined plane, say sigma n and tau. So we have to determine what is the value of sigma n and tau in this most complex stress system. Now we are giving the name, say A, B, C. So if we draw the stress element, then the stress element becomes sigma x is acting along x direction, sigma y stress is acting along y direction, and let sigma n and tau is the stress developed on inclined plane which is at an angle theta with x direction. Now in terms of force, if we express, give the name first A, B, C, considering width of the element is unity. Now the force acting along this direction, that is along x direction, is equal to sigma x into BC. Along y direction the force acting is sigma y into AB, and the force acting on inclined plane in normal direction is given by sigma n into AC, and along tangential direction the force acting is given by tau into AC. So these are the four forces acting on the element, as well as the shear stresses are also acting. So along a y direction, what is the stress acting on this face? The shear stress is acting, so that shear force will be tau xy into BC. And on y face also the shear stress is acting, the value will be tau xy into AB. So total number of forces acting on the element are 6. So 6 forces are acting on the element simultaneously. Now we will go for vector diagram. So consider an initial point. From this point along x direction, the force acting is sigma x into BC. So this is the force which is acting along y direction, x direction. Along y direction, the force acting is sigma y into AB. Now along y direction also this force acting, that is tau xy into BC, that is along upward direction, and along x direction towards left the force acting is tau xy into AB. And two forces developed on the inclined plane, that is at an angle theta with x direction, that force is given by tau into AC. So this is the force, tau into AC, and with this at an angle 90 degree the normal force is acting, that is sigma n into AC. So in this vector diagram total 6 number of forces are acting. Sigma x into BC, it is acting in rightward direction, it is acting in rightward direction. Tau xy into BC, it is acting along y direction in upward sense, upward direction. So tau xy into BC. On y face, sigma y into AB, it is acting in downward direction. Tau xy into AB, it is acting towards left direction, and tau into AC, that force, that is the tangential force which is acting at an angle theta with x direction, and sigma n into AC, the normal force acting on inclined plane which is perpendicular to this direction, and this angle is given as theta. Now we have to find tau into AC, that is we have to determine tau as well as sigma n, tau and sigma n. So don't disturb these two forces, and other forces will be resolved into two components. So for resolving, so geometrical construction I am doing, that is extend this line, so this angle will be theta. Now extend this line, so this angle is 90 minus theta, so this angle will be theta, and okay, so this angle is the opposite angle to this, that is also theta. So now we will resolve the other forces other than these two forces. So we will not disturb these two forces because we are going to determine sigma n and tau. So we will not disturb these two forces, other forces will be resolved into two components. Now take one by one. Sigma x into BC, so if we resolve this force along this direction, the component will be sigma x BC cos theta, and along this direction will be sigma x BC sin theta. So now this force is resolved, so we are cancelling this force. Now take this force, so sigma y into AB, so along this direction it will be sigma y into AB cos theta, and along this direction it will be sigma y AB sin theta. So we are cancelling this force because it is already resolved into two components. Now consider this force tau xy AB, the component along this direction will be tau xy AB cos theta, and along this direction it will be tau xy AB sin theta. Okay, this force is already resolved, so we are cancelling this. Now left with this force tau xy BC. So in this direction it will be tau xy BC cos theta, and along this direction it will be tau xy BC sin theta. So this force is already resolved, so we are cancelling. So now you can see the forces are present along this line as well as along this line. So for equilibrium of the body or equilibrium of the element, so this force, that is total sum of all these forces, will be equal to these forces, and sum of these forces also will be equal to sum of these forces. So now balancing the forces. So first we will take sigma n. So we can write sigma n into AC plus tau xy AB sin theta plus tau xy BC cos theta is equal to, we can write this one, that is sigma x BC sin theta plus sigma y AB cos theta. Therefore sigma n into AC we can write, so these two will go to the right side and the sign will change, that is sigma x BC sin theta plus sigma y AB cos theta minus tau xy AB sin theta minus tau xy BC cos theta. Therefore sigma n becomes, so divide by AC, so sigma x BC by AC, so BC by AC, that is perpendicular by base, that is sin theta into sin theta, so it will give sin square theta, plus sigma y into AB by AC, so AB base by hypotenuse, so it will give cos theta, so it will be cos square theta, minus tau xy AB by AC, so perpendicular by hypotenuse, so that is sin theta, so that is AB the base by hypotenuse, means cos theta into sin theta, so sin theta cos theta minus tau xy BC by AC, so BC that is perpendicular by hypotenuse, means sin theta cos theta. So that will give sigma x, we can write sin square theta is equal to 1 minus cos 2 theta plus sigma y cos square theta, so we can write sigma x by 2, sigma y by 2 cos square theta is equal to 1 plus cos 2 theta minus tau xy sin theta cos theta, tau xy sin theta cos theta, so minus 2 tau xy sin theta cos theta. Okay, so if we take the first part, so it will be sigma x by 2 plus sigma y by 2, so we can write sigma x plus sigma y by 2 plus, see, sigma x by 2 minus sigma x by 2 cos 2 theta plus sigma y by 2 cos 2 theta, so cos 2 theta we can take common, so it will be sigma y minus sigma x by 2 cos 2 theta minus tau xy into 2 sin theta cos theta is equal to sin 2 theta. So tau xy sin 2 theta. So this is the standard form of this sigma n value. So I am writing here sigma n is equal to sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta minus tau xy sin 2 theta. So this is the value of sigma n which is developed perpendicular to the inclined plane. Now we will find out what is the shear stress developed on the inclined plane. To find the shear stress which is developed on the inclined plane, so we will equate this to these forces. So we can write tau into AC plus sigma x BC cos theta plus tau xy BC sin theta, that will be equated to sigma y into AB into sin theta plus tau xy into AB into cos theta. Okay, so now next is the mathematical part. So therefore tau into AC is equal to, we can write sigma y AB sin theta plus tau xy AB cos theta minus sigma x BC cos theta sigma x BC cos theta minus tau xy BC sin theta. Therefore tau will come as tau. So divide by AC, so it will be sigma y AB by AC. So from this figure we can find AB by AC, that is cos theta. So cos theta into sin theta. So we can write sin theta cos theta plus tau xy AB by AC. So AB by AC, that is cos theta into cos theta AB by AC, AB by AC, that is cos theta into sin theta. Now tau xy into AB by AC, AB by AC, that is also cos theta into cos theta is equal to cos square theta. Okay, minus sigma x into BC by AC, that is sin theta into cos theta, sin theta cos theta, then minus tau xy BC by AC, that is sin theta is sin square theta. So this one and this one we are taking. So sigma or tau is equal to, you can write sigma y by 2 sin theta cos theta, that is sin 2 theta, and this one minus sigma x by 2 sin theta cos theta is equal to sin 2 theta. Okay, minus tau xy by 2, that is cos square theta 1 minus 1 plus 2 cos square theta 1 plus cos 2 theta minus tau xy by 2 into sin square theta is equal to 1 minus cos 2 theta. So sigma y by 2, 2 sin theta cos theta, that will be sin 2 theta tau xy into cos square theta. Okay, so next we are taking this one, sigma x by 2, 2 sin theta cos theta, that is sin 2 theta, then tau xy cos square theta, tau xy take, by 2 into 2 cos square theta is equal to 1 plus cos 2 theta minus tau xy 2 sin square theta, tau xy by 2 into 2 sin square theta is equal to 1 minus cos 2 theta. Okay, so next taking common, that is sin 2 theta. So sigma y minus sigma x by 2 into sin 2 theta. Okay, then this one tau xy by 2 minus tau xy by 2, we are taking common, so it will be 1 plus cos 2 theta, so minus we have taken common, plus 1 minus cos 2 theta. So we are taking common minus tau xy 2, sorry. So 1 is the plus 1. Okay, this one is minus, this one is minus. So tau is equal to this one plus this. This one is plus. Okay, this symbol, this sign is plus. Okay, tau xy by 2, 1 plus cos 2. Okay, that is fine. Now tau is equal to sigma y by 2 sin 2 theta minus sigma x by 2 sin 2 theta plus tau xy by 2 into 1 plus cos 2 theta minus tau xy by 2 1 minus cos 2 theta. So we are taking common tau xy by 2. So then it will be 1 plus cos 2 theta minus 1 plus cos 2 theta. Okay. So this 1 will cancel out and it will give sigma y minus sigma x by 2 sin 2 theta plus tau xy by 2 into 2 cos 2 theta, 2 cos 2 theta, so 2 will cancel out, so tau xy cos 2 theta. So that means tau is coming as, okay, so we have seen these two values, that is sigma n and tau values. So sigma n is given by sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta minus tau xy sin 2 theta, and tau is given by, that is sigma y minus sigma x by 2 sin 2 theta plus tau xy cos 2 theta. So we have seen the stresses on an inclined plane, that is sigma n and tau. Sigma n is given by sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta minus tau xy sin 2 theta, and tau is given by sigma y minus sigma x by 2 sin 2 theta plus tau xy cos 2 theta. So if we see this complex stress system, so the stress system on this element was, that is sigma x was acting along x direction and sigma y was acting along y direction, and tau xy was acting in anticlockwise sense on x phase and tau xy was acting as clockwise sense on y phase. So these four forces was acting on the element, and after derivation we have got sigma n and tau value on the inclined plane, that is AC. So on inclined plane sigma n value we have got sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta minus tau xy sin 2 theta, and tau value on inclined plane AC is given by sigma y minus sigma x by 2 sin 2 theta plus tau xy cos 2 theta. So the values will be given in the problem. Just put the value considering the sign convention. So I will come afterwards regarding this sign convention. This angle is theta. The theta is the angle made by inclined plane with x direction but in anti-clockwise sense. Means theta is measured from here to here in anti-clockwise sense with x direction. Now we will see the next derivation, that is the body is under pure shear stress. So if the body is under pure shear stress, or simply it is under pure shear, so that means only shear stress is acting over the body. So in that case we are going to find the stresses on an inclined plane. So this is the body, stressed body, and only shear stress is acting over the body. Say on x phase shear stress is in anti-clockwise sense, tau xy. So complementary shear stress will develop on phase y, so that is also equal to tau xy. And this is the plane AC. AC is the inclined plane. On inclined plane, what should be the condition of stress? So there are two stresses developed on inclined plane, that is sigma n and tau. We don't know. We are going to find sigma n and tau value. So we are drawing separately the stress element. Now the stress element is making an angle theta with x direction in anti-clockwise sense. So this is your ABC. AC is the inclined plane, and on phase, that is x phase, tau xy stress is acting, and on y phase also tau xy stress is acting in clockwise sense. Now this angle is theta. Now we will draw the vector diagram. So consider an initial point. From that point, the stress, this is in terms of force. If we express it, the force on phase y phase, that is tau xy into AB, and on x phase tau xy into BC. Now the force which is acting from this initial point towards left direction, that is tau xy into AB, and along y direction the stress acting is tau xy into BC. Now here there are two stresses developed here. So in terms of force we can write, that is sigma n into AC. Force is acting perpendicular to the direction of the plane, that is inclined plane, and tau into AC is the force acting tangential to the surface AC. Now, so this is at an angle theta. So say this is your x-axis. So with this at an angle theta, the stress acting is tau into AC. So just I am writing again. So that is tau xy into BC. Okay, with this at an angle 90 degree, the normal stress is acting. That normal stress value, normal force will be equal to sigma n into AC. So these are the four forces are acting from this initial point. This is the vector diagram we have drawn from this element. The four forces are acting. Now we are going to find, that is, tau and sigma n value, sigma n and tau value. So we will not disturb these two, and the rest two forces will resolve into two components. Now this angle we know, this is the theta angle, same angle. So this angle will be 90 minus theta. So this angle will be theta. And so if we draw this, extend this line, so this angle also will be theta. Okay. So after this, we will resolve these into two components, that is tau xy bc cos theta, so it will come in this direction, tau xy bc cos theta, and in this direction will be tau xy bc sin theta, tau xy bc sin theta. And if we, so this one is resolved. Next we will resolve tau xy into AB force. So if we resolve this into two components, one component in theta direction, that is tau xy AB cos theta, and along this direction will be tau xy AB sin theta. So we have got all the forces, means the forces are acting along this direction or along this direction. So for equilibrium of the element, so these forces will be, the sum of these forces will be 0. That is, we can write sigma n into AC, sigma n into AC plus tau xy bc cos theta plus tau xy ab sin theta is equal to 0, because in other direction there is no force. So the sum of the forces along this direction, it will be 0. So which gives sigma n into AC, that will be equal to minus tau xy bc cos theta plus minus tau xy AB sin theta. Now dividing by AC, we get sigma n, that will be equal to minus tau xy into BC by AC. So BC by AC, that is sin theta into cos theta, sin theta into cos theta minus tau xy into AB by AC, AB by AC, that is cos theta into sin theta. So is equal to minus 2 tau xy sin theta cos theta, or we can get minus tau xy into sin 2 theta. So we have got sigma n value. What is sigma n value? That is minus minus tau xy sin 2 theta. So that is the sigma n value which is acting or which is developed on plane AC. And now next we will go to find out, that is, what is the shear stress developed on inclined plane. So for shear stress, so we will equate these two. For equilibrium, we can write tau into AC plus tau xy into BC into sin theta, and that will be equated to tau xy into AB into cos theta. Okay, so that means tau into AC, that will be equal to tau xy AB cos theta minus tau xy bc sin theta. So tau becomes tau xy divided by ac. So ab by ac. So ab by ac, that is cos theta. Cos theta into cos theta is equal to cos square theta minus tau xy bc by ac. bc by ac. bc by ac means sin theta into sin theta sin square theta. So that will be equal to tau xy by 2 into 2 cos square theta 1 plus cos 2 theta minus tau xy by 2 into 1 minus cos 2 theta. So it will be equal to tau xy by 2, you can take common, tau xy by 2 into 1 plus cos 2 theta minus 1 plus cos 2 theta. So that will be 2 cos 2 theta, 2 will cancel out, so it will be tau xy into cos 2 theta. So that means we have got tau is equal to tau xy cos 2 theta. So this is the result. So that when the body is under only shear stresses, or you can say body is under pure shear, so that time the sigma n and tau developed on the inclined plane is given by sigma n is equal to tau x minus tau xy sin 2 theta and tau is equal to tau xy cos 2 theta. So I hope all these 4 derivations are understood. So 2 derivations are solved in last video, and in this video we have solved these 2 derivations. So I hope this will solve your problem. Just you put the value, the result will come. But only one thing you face, that is the sign convention. So if you don't put the sign correctly, your result may be wrong. So that's why, so in next video we will discuss about the sign conventions. Okay, that's all for this video. We will meet you soon. Thank you. We would continue further on this topic in the next session. Keep being connected with us and ask any question in the comment section. Like, share, subscribe, and don't forget to press the bell icon to get notified for future videos. Thank you and see you soon.